Hey there, hi there, ho there. Welcome to Unit 4. So this one is all about, as you see, tsunamis. Tsunamis can be triggered a few different ways, so we'll talk about that. They are kind of a next logical step in discussing natural hazards after we discuss earthquakes, because that's one of the main triggers. This background image is an example of a tsunami that happened in Japan, in Miyako. The ocean rose up, spilt over these protective walls, and flooded the city. So, what are some triggers to a tsunami? What could cause a tsunami? I mentioned one, earthquakes. So what else could get a bunch of ocean water moving? Think about that. What else could get a bunch of ocean water moving? Well, tsunamis are caused by a sudden vertical displacement of water. Water needs to be moved vertically. So again, what could cause water to move vertically? The wind blows horizontally. That's what causes normal waves. So tsunamis, sometimes incorrectly called tidal waves, need vertical displacement. So wind, storms, they don't create tsunamis. We need vertical displacement. We need water moving up or down. What could do that on a large scale? Well, tsunamis can be triggered typically in a few different ways. Large earthquakes, landslides, volcanic eruptions, and large impacts from comets or asteroids, which can produce mega tsunamis. We'll describe each of these here momentarily. So here's just some historic tsunamis that have occurred. You can see highlighted, most of them are due to earthquakes. In fact, all but one are due to an earthquake. This lone volcanic collapse in Indonesia in 1883. As far as just in recent recorded history, this is not every tsunami that ever occurred because we don't have records on some of them. Some interesting ones would definitely be the Sumatran earthquake, magnitude 9.1 on the Richter scale. That happened in Indonesia. That resulting earthquake and tsunami killed 230,000 people, which would be the deadliest in recorded history. The one that we saw at the beginning of this presentation, that was in 2011 in Japan, also a 9.1 magnitude scale, only killing 20,000 people. Well, we kind of touched on this in lab when we were looking in plate tectonics. Well, if they're the same magnitude earthquake and they create a tsunami, why is there so many more people dead from this Indonesian earthquake than in Japan? Think about infrastructure. Think about warning systems and technology to warn people and medical care. All of that is going to exist in much higher levels in Japan than in Indonesia. So let's talk about those 4 different triggers. So tsunamis caused by earthquakes usually, not always, but usually takes an earthquake of magnitude 7.5 on the Richter scale or greater. Usually, it's not always the case, but it usually has to be that or greater. They're more common, though, when you're getting at a magnitude 9.0 or greater. So, but usually it takes 7.5 or greater. It could be a little less, just usually around 7.5 or higher. Because it's this strength of earthquake that's going to create enough vertical displacement of the seafloor, and these are typically created by megathrust earthquakes near convergent boundary subduction zones. This is where you can get a lot of upward or downward movement that will displace this kind of large mass of water. So you think of 2 plates coming at each other. One starts to subduct. As it does, it kind of takes that overlying plate down with it, and then if there's some slippage, that plate snaps back, and when that plate snaps back, all the ocean water that's above it gets thrown up and then splashes back down and radiates in all directions. That's a tsunami. So when a tsunami is caused by an earthquake, it triggers kind of a 4-stage process. So you have some sort of rupture. You can see this looks like some sort of reverse fault. The hanging wall went up, looks like. So that hanging wall, as it went up, right, moved that water upwards. So you're getting this vertical displacement. And as it splashed back down, the tsunami moves very rapidly in the deeper oceans, up to 900 kilometers per hour. That's about as fast as a jetliner. But the height of the wave is only about a meter. So it's only about, this much out in the deep ocean. It's moving very fast, but you get this kind of like, if you're in a big boat, you kind of get this little ripple out in the deep ocean. But as the tsunami nears land, it slows down to about 45 kilometers an hour. That's about 30 miles an hour. But it's squeezed upwards. Think about the highway. Let's say you got all these cars, they're driving on the highway, and they're all going, 60 miles an hour. If the one in front all of a sudden slows down, well, all the other ones are going to just crash and build up behind it. Well, same thing here. As a tsunami kind of gets closer to land, it kind of gets squeezed as the seafloor kind of rises. Therefore, it slows down the front, allowing all that water from behind to kind of, which is still racing towards it, to kind of race towards it and build up. And then you get this big buildup of a wave. This is where tsunamis start to get real big. They increase in height. And as they kind of make their way on land, they destroy everything in its path. Oftentimes, before a large tsunami, the ocean will recede, and it's building up, and then it comes crashing back on. And tsunamis usually come in waves, usually a number of different large waves, and each one's getting deeper and bigger and deeper and bigger and going in further and further and further. By the way, 900 kilometers an hour is about 560 miles per hour. It's close. 45 kilometers per hour, about 28. So it goes from 560 miles per hour to 28 miles per hour. That's going to, bunch up a lot of water behind it. So that's kind of earthquakes. Landslides. So either you get a landslide from above the water, sliding into the water, pushing the water down, and then it back up and then splashes out. Or you get a landslide below water, so you kind of get this material slumping down. It kind of draws the water down with it before it splashes back up, creating a tsunami. So surface landslides, really quickly depositing material into the earth, or submarine landslides, like in this image, when the landslide occurs below water. Again, in both cases, you're displacing water vertically. Vertical means up or down. On land, landslides crashing into bodies of water can cause tsunamis. A great example of that is Lituya Bay in Alaska. 30.5 million cubic meters of rock. That's a large volume of rock, kind of just slid off this mountain face and fell into the ocean. The bay water surged 524 meters. That's 1,720 feet above normal. So it created this kind of big initial wave that was 1,720 feet high. That's the highest kind of run up in tsunami recorded history. So here was the large slab of mountain that kind of slipped down into this bay in Alaska, and it caused the water, think about a large cannonball, right? Just a big cannonball just sliding like a cannonball into the pool, like just a large amount of material hitting that water. It caused that water to go up and over the little mountain that was just kind of across from it. That's about just about a mile away. So 524 feet, 1,720 feet. That's about the height of One World Trade Center in New York City. The spire is just a little bit taller than that. So imagine a wave about that tall. So that's how big it was initially. And you can see it kind of decreased in height, but it's still rather large. Just to give you some sense of how big that would be. If we consider the height of Cardinal Stadium, how big is 524 meters? 1, 2, 3, 4, 5, 6, 7, 8 of those. 8 and a little bit more. That's how big this wave was. So take Cardinal Stadium, put 8 on top of that, or put 7 more on top of that, and the wave was still higher than that, just for some reference. So you can see the scar where the rock fell in, and then the scar on the other side where the tsunami just kind of devastated, just ripped all the trees out. But you can see, after it made its way over that initial hump, it was still pretty high. You can see how it just stripped the trees as it kind of went along after that initial kind of run up. So you can see the trees were moved by the wave, the original location of the landslide, and then just kind of that tsunami made its way outward. So yeah, it was still, after it came off that high point, 220 feet high, it was still 30 feet high by the time it reached the edge of Lituya Bay. So it's a big tsunami. But and those are typically on the smaller side. Like after it left the bay, it didn't really do too much around in the local area, yes, but nothing, globally. Volcanoes can cause tsunamis, especially if you have volcanic activity underwater. So you have an underwater explosion, kind of like what we saw in Tonga, not but a couple months ago. So when you have an explosion, you're moving water up, and as it comes back down, it sloshes out in all directions. And also a volcanic collapse, similar to a landslide. Volcanoes, they don't always just erupt up. Sometimes you can create a large landslide where parts of the volcano kind of just slough off. That's what happened to Mount St. Helens. And if it's right next to the ocean, it can create a tsunami. And then finally, a very large impact. Asteroid, comet. We'll talk about those specifically impacts. That's a separate unit of hazards later in the semester. But, if something very large, just like when you throw a big rock into a pond, well, same thing here. You got a big rock going real fast. Hits the ocean, it's going to create a tsunami, a mega tsunami at that. So let's go ahead and pause here. So that's kind of the triggers of a tsunami. So when we come back, we're going to look at areas of Earth that are most at risk from tsunamis. See you back here in just a second.